Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. In this video we are going to learn about basics of sequential circuits. Okay, that is, what is the difference between sequential circuits and combinational circuits, and the basic elements of sequential circuits, that is latches and flip-flops. What is the difference between latches and flip-flops we are going to see in this video, right? If you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so what is the difference between sequential circuits and combinational circuits? And the first difference you have to remember is, in sequential circuits have memory. Okay, so it will have, they have the memory, and combinational circuits does not have any memory. So they does not have any memory. This is the first difference between sequential circuits and combinational circuits. The second, sequential circuits are slower than combinational circuits. Right, so sequential circuits are always slower when compared to combinational circuits. That is, they take more time to produce the output when compared to combinational circuits. Third difference is, in sequential circuits the next state, okay, so next state is a function of present inputs and past outputs, or past states we'll say. Okay, so in sequential circuits, if you want to have the output, that output, when you apply some input, we'll get the output. So that output in sequential circuits, we'll call that as next state. Okay, since memory is present, it is having past output storage. Past output storage is present because it is having memory. So next state, that is the output for the present input. For the present input, what is the output? It is called as next state. So this next state, that is next state output, is a function of present input, what inputs you are applying for the memory elements, and it is also function of past outputs because it is already stored inside the memory elements. Right, so this is very important point. And in combinational circuits, output is always dependent on combination of present input only. It does not have any past output because it does not have any memory elements. Okay, so the fourth difference is, in sequential circuits, the basic elements are latches and flip-flops. So the basic elements of sequential circuits are latches and flip-flops, whereas in combinational circuits, the basic elements are logic gates. That means we design sequential circuits using latches and flip-flops, and similarly we design combinational circuits using logic gates. So that is why they are called as basic elements. Okay, so these are the four important points which you have to remember for differences between sequential circuits and combinational circuits. Okay, so now we'll see the differences between latches and flip-flops. So these two are the basic elements of sequential circuits. So we'll see the differences between latches and flip-flops. So if you take a SR flip-flop or SR latch, so SR latch will look like this. S and R inputs. Okay, so this is enable input. This is Q and this is Q bar. Similarly, so this is SR latch. Similarly, SR flip-flop or SR clocked flip-flop will say. Okay, so this is S input, this is R input, this is clock input, Q bar. Okay, similarly, if you take another type of clocked input, so this is Q bar. Okay, so this is clock. Okay, so this is the difference in block diagram of latch and flip-flop. Okay, so latches, this is very important point which you have to remember. Latches are level triggered circuits. Latches are level triggered circuits, and flip-flops are edge triggered circuits. Okay, so latches are level triggered circuits and flip-flops are edge triggered circuits. Level triggered, it can be again positive level triggered or negative level triggered. Edge trigger also positive edge triggered and negative edge triggered. Okay, so latches and flip-flops functionality is same. Functionality means when you apply same S and R inputs, if you apply the S and R inputs same for both latch and also for flip-flop, you will get the same outputs for Q and Q bar. Q and Q bar will have the same outputs for both latch and flip-flop. The only difference exists in the way they change their output. Okay, so the difference lies in the way they change their output. So in the latches, so if you make enable input is equal to 1, okay, so when it is high, so when you make enable input is equal to 1, when it is when we make enable input is equal to 1 for positive edge triggered, and for negative edge triggered we have to make positive level triggered and positive negative level triggered. So enable is equal to 0. So this is for positive level triggered latch and this is for negative level triggered latch. So if you give enable input is equal to 1 for positive level triggered latch, and if enable input is equal to 0 for negative level triggered latch, so we will say that enable input is made high. So when you make enable input is when you make this enable input high, then if you change the inputs, S and R, then output changes at any instant. Okay, so output changes at any instant. This is in the case of latch. So in latch, only condition is if enable input is equal to 1. So for this is for positive leveled. So this is the block diagram of positive leveled latch. So if you want to draw it, negative level triggered, so this is negative level triggered, Q bar. So this bubble represents it is a negative input. Okay, so for this you have to give enable input is equal to 0, so that when you give 0 for a NOT gate, this represents a complement operation, that is the negation operation or NOT gate operation. So when you give enable input is equal to 0, so output of NOT gate will be 1, so that EN will become 1. so that we can say that enable input is made high. So when enable input is made high, if you give S and R, if you change these inputs, then corresponding changes in the output occurs at any instant. Okay, so without depending on the time, it at any instant, if you make changes in the input, then you'll have changes in the output. Okay, so this is how the output changes in the case of latch. Okay, so we have seen the case of latch, right? So if you have the flip-flop now, okay, so I'm drawing the two types of flip-flops, SR. Okay, so this is called as negative edge triggered flip-flop, and this is positive edge triggered flip-flop. Okay, so based on the bubble here, so if the bubble is present here at the clock input, so it is called as negative edge. If no bubble is there, it is called as positive edge. So clock is a 50% duty cycle square waveform. Very, very important. So terminology also you have to remember. So clock is a 50% duty cycle square waveform. 50% duty cycle. 50% duty cycle means T on is equal to T off, or in terms of negative and positive, so whatever negative cycle area is there, so that is also equal to the positive cycle area. So T on is equal to duty cycle square waveform. What is clock signal is 50% duty cycle square waveform. Okay, so this is the clock signal like this, right? So this is called as positive edge or positive triggering edge. Positive triggering. So all this is called as positive triggering, and this are called negative triggering, negative edge triggering, negative edges of the clock pulse. Okay, so this positive edge is also called rising edge. Positive edge is also called rising edge, or it is also called leading edge. And negative edge is also called falling edge, or it is also called trailing edge. Okay, so as I have told you, when S and R inputs are same, then Q and Q bar, that is outputs, are also same in the case of latch and flip-flop. So in latch and flip-flop there is no change. If the inputs are same, then outputs are also same, but the change is only with respect to the time where it changes its output. So that time instance, the difference exists in the time instance where it changes its output. Okay, so in latch, whenever enable input is made high, when enable input is made high, then at any instant you can change the output. You can change the output by making the corresponding changes in the input at any instant. Okay, so at any instant you can make this. Only condition is enable input should be made high. Okay, so but in the case of latch, flip-flop, you cannot change, you cannot do like this. So if you make Suppose if you have given I am taking the example as positive, this is positive edge triggered flip-flop, so I am taking S is equal to 0 and R is equal to 0, 1. So at this instant I am giving S is equal to 0 and R is equal to 1. You will get some output. Okay, so that output we'll discuss in the next class. Okay, so you'll get some output. Now if you want to give S is equal to 1 and R is equal to 0. Now if you want to change the input, so we want to change it to S is equal to 1 and R is equal to 0. So this we can do, or this input we can give only at next positive edge only. That is, at this instant only you can give S is equal to 1 and R is equal to 0. Okay, because it is a positive edge triggered flip-flop. It is a positive edge triggered flip-flop. You can give inputs, or you can have the change in outputs only at corresponding edge triggerings. If it is positive edge triggered flip-flop, you can give the inputs only at corresponding positive clock pulse, or positive edge of the clock pulse. And if you want to change again, so if you want to change again, you can change like this: S is equal to 0, R is equal to 1 at the next positive clock pulse. Similarly for negative edge triggering also. Okay, so even in between if you change, so here if you change S is equal to 0 and R is equal to 1, so even in between the clock pulse, because we know the time period of the clock pulse, so in between the time period also, if you change the input, there will be no change in the output. Even in between also, at the negative edge, suppose at negative edge you have given S is equal to 0 and R is equal to 1, for a positive edge triggered flip-flop there will be no change in the output. So output will be in the same state as the previous input. So this is the previous input, so whatever the output you have got at this input, the same output exists until next positive clock pulse. And at the arrival of next positive clock pulse, the flip-flop will checks its input. If there is change in input, it changes its corresponding output. If there is no change, it continues in the same state. Okay, so this is the difference between latch and flip-flop. So in latch, at any instant you can change the output if only condition is enable input should be made high. But in flip-flop you can change the outputs only at corresponding edges. If it is positive edge flip-flops, you are making the circuit using positive edge flip-flops, you can change the output only at positive edges only. Okay.